Welcome to some extra practice here for you. The first questions, 1 and 2, I told you that I'm actually going to just have you do graphing. So I'm just going to go through the solution of just graphing. When I look at this first equation of this system here, I notice that it's an ellipse. That's my conic recognition because I see that the coefficients are different, but I have to have that equal to 1. So I'm going to divide everything here by 16, and that will give me x squared over 4 plus y squared over 16 equal to 1. So I'm going to do my best to sketch that. Basically, remember that means my a value is 2 and my b value is 4. So from the center of 0, 0, I go over 2 in both directions. 1, 2, 3, 4. 1, 2, 3, 4. And to the best of my ability on this pad, I will sketch that ellipse. All right, and then I'll switch colors to blue here. We need to know what this is. Well, that is not squared anywhere. There's no nonlinear component, so it's just a linear equation. So basically, I'm going to solve this for y because that's what I'm used to. And if I get it in a slope-intercept form, I can graph. So if I divide everything by -2, that'll give me 2x plus 4. So I have a line here where I go up 4. And I go up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And when I sketch that line, I will actually see that this ellipse intersects this line in 2 places. So my solutions to this problem are 0, 4, and -2, 0. Okay, so those are my 2 answers. Now, just a quick chat before I move on. If I would have asked you this question as algebra, so no graph, just algebraic, I still would have gotten this y equals here, and then I would have put it up into the other equation for y, and I would have went through a bunch of algebra there to get my x value, and then I would plug it into this second equation to try to come up with these ordered pairs. All right, moving along to the second one, we've been working a lot with parabolas that are horizontal. So remember, just a quick little refresher here, standard form, sorry, that's not correct, vertex form looks like this, y minus actually k quantity squared plus h. So when it's horizontal parabola like this, that's what it looks like. So the big key is that you have a vertex. You have to look at the h value, which is right here. So we have a vertex at -2, and then in here it says minus k, so that means my value is actually -1. So -2, -1. It says plus h, so my actual value is -2. So there's our vertex. So I have to go left 2 and down 1. Okay, so I'm right here. And then I go up 1 over 1, down 1 over 1. This graph isn't the best on here, try my best. Up 2 over 1, 2, 3, 4. Down 2 over 1, 2, 3, 4, and then again 5, 6, 7, 8, 9. Make this symmetric. This should be a parabola, horizontal, open to the right. We'll see how this intersects in a second. But once again, I'll switch colors to blue here. We have a linear equation. So if we just subtract the x from both sides, we get -x minus 3. That means my y-intercept is 1, 2, 3, which would be, looks like right here. Did I do that correct? Good. Up 1, left 1, up 1, left 1. And this is actually intersecting here and here. Okay, so that would be actually at our vertex, we have a point of intersection. So one of the answers is -2, -1. And then the other one here is -1, -2, it looks like. Okay. Now, algebraically, what I would do if we were doing this one algebraically is I would go to here, and then I would plug it in there. And if you want to do algebraically to verify your graphical one, that's fine too. One cool thing to figure out also to check your work is these are your 2 answers, right? Like any system, if you plug them in, they should work. If I put -2, -1 back into both of these equations, you'll see that they both work out. So they're both good answers there. Okay, now we're going to cruise on down to this one. We have to set up 2 equations for this problem. The product of 2 numbers is 10. So that would be the x times y equals 10. Product means multiplication. Don't mess that up with addition. You'll be way down the wrong path on this problem. Sum is addition. They're squares. So if you square each of those numbers, and you get the sum of them coming out to 101. All right, so we've done a bunch of these now. Hopefully it's starting to become a little bit easier to get started. Basically, it doesn't matter if you solve for x or y. I'll solve for y because most of you do. We're going to take y equal to 10 over x, and then we're going to take that and we're going to plug it right back in there. So this becomes x squared plus 10 over x. Quantity squared equals 101. And then we have x squared plus a number squared is literally that fraction times itself. So we're going to get 100 over x squared. And we'll get 101. Okay, then we need to multiply everything, both sides here, by x squared. And the reason I'm doing this is just to get the x squared out of the denominator. So what's this going to turn into? This is going to turn into x to the 4th power plus just the hundo equals 101x squared. So now my instincts take over. Solving this, I want to get this term over here, still plus 100 equals 0. And I don't think this one takes too long for you to practice and understand or to guess and check to see that the factors of 100 that give you 101 are 1 and 100. So I'm going to have x squared minus 1 and x squared minus 100. And then that will give me x equals plus or minus 1 and x equals plus or minus 10. Okay, remember this is a situation where we would set up all these ordered pairs at this point. Like if this was not a problem like this where they're asking for just any numbers satisfying, then you would do this. You would plug in a 1. Well, when I put in a 1, I get a 10. When I plug in a negative 1, I get a negative 10. When I plug in a 10 into here, I get a 1, and when I plug in a negative 10, I get a negative 1. But here's the deal. For this problem, they're saying find any numbers that satisfy. So really, my final answer here, I should just say 1 and 10. That's a number pair. And then negative 1 and negative 10. Hope that helps. Uh-oh. Here we go. Uh-oh. I hope I can get this to cancel.